Hello everyone. I suggest we start because time is limited and we have a lot of stuff to share. It's great to see so many of you in the room. I'd like to welcome you on behalf of the Hilti Foundation and of our colleagues of the BASE Bahay Foundation from Manila. My name is Johan Ba. I lead the work of the Hilti Foundation in the field of affordable housing and technology. So what are we trying to achieve in affordable housing and technology? For me, it's really making construction better, focused on the needs of low-income families, mostly in the developing countries and emerging economies of the Global South. And I hope you had the chance to see the little exhibition that's just outside this room, which gives you an impression of all the projects that we run in affordable housing and technology. There will also be a chance after our conversation. I apologize to all of our online participants. There's no chance for you to see the exhibition, but I'm very glad to have you in the room digitally. So when we look at affordable housing and technology, I think bamboo has been at the center of our work at the Hilti Foundation for the longest time, and most of you have seen the beautiful houses that we've built in the Philippines. And I'm very glad we have my team of the BASE Bahay Foundation with us today because they champion bamboo since more than 10 years, and I think it's probably 3 years or even more that we last time shared the news to a wider audience at Hilti. Why bamboo? Bamboo has many advantages in our view. First of all, it's green. It captures more carbon than any tree that I would know of. Second, it's affordable. It grows in abundant amounts in most countries of the Global South, which makes it a very accessible building material. And it basically comes at no or very little cost when you harvest it, especially when you harvest wild bamboo. Most importantly for us, it's resilient. Bamboo is strong and flexible at the same time, which makes it a perfect building material. Why do people not really use it so far? In our view, because it's been vernacular. Most families that have used bamboo as a building material have built a little shack with their own hands, and the perception that people have of bamboo is the house collapses in the first wind or in the first storm. In our view, it's not a problem of the material, it's a problem of execution. And lastly, bamboo is local. So it not only serves as a material that helps families build better, it also gives benefit to local economies, especially in the more remote parts of the countries in which we work. It really helps create economic development. So we are active in this field since more than 10 years. And over this time, we've built more than 1,500 social housing units in the Philippines and also in Nepal. And we believe, and we're certain from the studies that we've done and from talking to the families who live in our houses, it's of great value for these families to start a journey into a better life and to really do better in terms of education, in terms of livability, in terms of feeling safe. And security is always something that families mention when they move into our homes. But we feel over the years, we've made so much progress in learning about construction with bamboo that we really developed into a competence center that helps make bamboo a standard building material. And we set the explicit target just recently that this is the route or the journey that we want to take with our colleagues of the BASE Bahay Foundation, that we make bamboo mainstream while focusing at the same time on the needs of low-income families in building social housing and help low-income families build better. And we did a couple of steps in this regard. We opened an innovation, a testing and research lab in Manila that really helps us have a continuous stream of innovation for bamboo construction that we can share with partners in the markets. We have a bamboo training academy that trains anyone who wants to build with bamboo, architects, developers, masons in using bamboo as a building material. And we help industries to take up bamboo as a building material, both along the entire supply chain, but also in execution. So there's a lot of things that we currently look into. And I keep myself short here because it's on the team to really present their great work. And with this, I would like to pass on to Pablo.
Thank you, Johan. My name is Pablo. I'm the general manager of BASE Bahay Foundation. Uh, I joined BASE Bahay 5 years ago. Before that, I was the general manager of Hilti Philippines. So I did quite a lot of lunch and learn to various customers. And usually, I really have to make the presentation very interesting. In some of the lunch and learn, the customers would be eating while I'm presenting. So I have to make my voice loud. I have to make myself very animated just to get their attention. And I'm so happy I get 100% of your attention today. And thank you for having us. What we will be showing you today is what we are currently doing in Base Bahay. Um, you can see making construction better. I guess it resonates to everyone with the strategy. And making construction better is not only at the high end construction market with our Hilti Power tools, but we try to cascade it all down to the affordable housing sector. And that is where we play. And that is where Hilti Foundation takes a very active role. Um, we are a non-profit organization. We are initiated and we are a brainchild of Hilti Foundation. We are actually a technology provider. We develop the technology, try to get as many partners as we can, try to network with different partners, whether it's in government, it's in private, it's in other non-government organizations, so we can build community and offer them the technology we generated. And that is through socialized housing. And when we talk about socialized housing, we try to make sure that it is up to the standard of health equality. And we talk about standards, high standards of construction in affordable housing. My colleague will tell you more about what we are currently doing in Base Bahay. So why socialized housing? Why the affordable housing sector? There is a huge housing gap around the world. And 1.6 billion, it's no joke. 1.6 billion units of housing is needed. And if I would just translate it, make it a little bit closer to home. In the Philippines, it's a 22 million unit gap in terms of the housing. Now, why the gap? Because there's a lot of issues in government funding. There is an issue in the design of the houses. There are issues in terms of the affordability. There are issues in the entire ecosystem that makes it work. So actually, the role of Johan in Hilti Foundation is not an easy one because it is such a complex topic. But that is why we're here. How can we address this gap in terms of generation of the technology using the same healthy quality and healthy standards? Now, again, next question, why bamboo? In the global south, it is an abundant material. And if you have this abundant material, it already supports you in terms of the affordability of the unit and the design. Now, the next question is how would you design it? How would you use this type of abundant material? Again, bamboo. Bamboo is a bio-based material. It is a carbon negative material. It is abundant. It's like a grass. It grows very fast. You don't need to cut the tree and wait for another 50 years before it starts growing up. So it's like grass. You can cut one pole and then wait for other poles to mature, and then you can continuously harvest. So it's a regenerative bio-based material. Now, Luis, my colleague here, will tell you why it hasn't been used as a construction mainstream material and what are the challenges. But those are the topics that I'll pass on to Luis. Now, if we use bio-based material immediately, that it answers right away the climate change topic. And we know that construction, building, concrete, steel, aluminum, I don't know if 22.7% part of the total global emission still valid. I know this has increased much more higher now than the transportation sector. So this also gives us an opportunity to address climate change. Okay, probably some of you have already seen this, but I think it's worth looking at this again.
As global inflation drives up construction material prices, affordable and innovative solutions for low-income families become even more critical. Our bamboo technology reduces costs by up to 50%, creating green and disaster-resilient homes. Emerging from processing centers, a transformative value chain now supplies engineered bamboo to construction sites. This dynamic engagement has evolved into a thriving bamboo housing industry in the Philippines, meeting affordable housing needs and fostering livelihood opportunities. In the global south, where the greatest housing problems exist, bamboo is abundant, making it even more likely that it will be the material of choice. Through global partnerships, bamboo has the potential to close the housing gap and help transform societies.
There. Thank you, Hilti Foundation, for providing that video. The technology that you'll hear today is called the cement bamboo frame technology. It is actually your timber frame. And the design, the knowledge behind it is it's very close to your hearts here in Switzerland, because in essence, it is timber frame design. But it's a little bit re-engineered to fit that affordable housing mindset. So if we are going to use this local material and use it for housing, we have to make sure that it's a permanent structure. It is not a structure that will fly off when a typhoon hits, or it gets demolished when an earthquake hits. So we designed it in the same way that it would be typhoon resistant, according to the codes, of course, compliant to the codes, earthquake resistant. And of course, if you have a partition between two units, you make sure that the fire rating is correct, that the wall is fire rated, even if you're using bamboo material. You know, just the fact that you're thinking in these terms, you're already thinking in an engineering level in terms of the design of an affordable housing. And of course, they would say, it would be eaten by termites. Yeah, the same thing with any other bio-based material. It would be susceptible to insect infestation, and their treatment is crucial. But at the end of the day, our objective is to help poor families. Give them this affordable housing unit. Give them this design that they can use. Now, the technology that you'll be seeing is like very similar to your prefab timber frames. So you can prefabricate panels, but instead of timber frames, you use whole bamboo poles. And then out of these panels, you can bring it to the site, assemble it like a Lego, and then you put the truss structure. The truss structure, together with all the shear wall frame, operates as a single unit. And this unit carries the entire live load, dead load, and all the design load needed to be carried by the structure. As an architectural cladding, you put now a thin cement mortar. Okay, there are many examples later on that you'll see more about this. So the structure in its simplest unit would be a panel, wherein the panel is composed of a frame, but instead of timber frame, you use a pole, bamboo poles. And then you need to have some sort of an architectural cladding. It could be also made of bamboo material. It could be a wire mesh, and then a thin coating of cement mortar. Just to give you to the non-technical, how does it look like when you assemble this? Actually, for us, before we join into the construction, we make sure that the site is already fully developed. And then the way you build foundation is similar to any type of houses. You prepare your foundation like a tie footing foundation, the same thing with your reinforcing bar. You do the base, and then the flooring, and then you have the sokalo, where you'll put all the panels. You'll put all the temperature rebars for your concrete flooring. Very typical to the current construction of how we do houses. And then you do the concrete floors, and then you assemble all the panels. You assemble it like a Lego. So there's a different team working on the panels, and there's a different team assembling the panel on site. So it's like the timber frame, right? And then even the trusses can also be modularized, including the lintel or the purlins. It's all made of bamboo poles. Then you put your roofing. It could be any type of materials. For architectural cladding, you can even use bamboo materials for the architectural cladding. Put a wire mesh, and then like a ferro cement, you plaster it. And then you apply the skim coating, very similar to what you do in your a mortar wall, and then you put the fascia board, the door, the windows, very easy. And the process can be taught and can be transferred to the community where we are currently working. This is a very simplified design. Why it look like an ordinary reinforced concrete house and not your beautiful bamboo buildings that you see in Bali, Indonesia, or in Vietnam? Let Luis answer that for you. So I'm transferring all the difficult topic to Luis here. So the finishing of the house looks like this. On the outside, it looks like your normal reinforced concrete or concrete hollow block. But when you look inside, it now depends on who will be receiving the house. They can have this style, or it could even be that one, the white one, depending on how the beneficiary would like the architectural finish of the inside of their house. Now, we would like to have as many Hilti members to know about what we're doing in BASE Bahay through Hilti Foundation. And one best form is in our EBB, or Engaged Beyond Business. We had Region A2 team headed by Alim Hirani, the current region head, and they did a house build in the Philippines using the same technology.
We at Hilti believe in building a better future. And it's through the work of the Hilti Foundation all over the world that we focus on affordable housing, technologies, on music for social change, and economic empowerment. Today here in the Philippines, we have a fantastic example of building affordable housing through the cement bamboo frame technology that enables us to hand over a house to underprivileged people who can build on a strong foundation. Having a home is the start to having a more sustainable and a self-reliant home and life. It's a fantastic opportunity, and looking forward to many of you coming to the Philippines and experiencing that on the ground firsthand.
Yeah, we're also looking forward seeing many of our Hilti employees join us in the Engage Beyond Business, and later during the Q&A you can ask more about that. Okay. Now our objective is to make bamboo as a mainstream construction material. And for us, many engineers and researchers and technical people in this room, if you would like to use a material like a bio-based material as a mainstream construction material, first it has to be in the codes, or at least the testing, the properties has to be standardized. And for you to be able to do that, you need research, full research to put all the data available into the codes. Why it has to be in the codes? Because if it is not in the codes, no one will build it. No one would specify it. No one would even teach it. And if there's no one doing anything about specification design, then there would be no demand. That is why through the BASE Innovation Center, through the Hilti Foundation, we initiated the research, the work on the codes, so that, and then start the technology transfer so we can really make this material a mainstream material for construction. Okay, I'll pass you on to my colleague here to discuss more about what we do in the BASE Innovation Center. Luis?
Thank you, Pablo. So Hello, everyone, and thank you for coming. I'm Luis Felipe Lopez, the head of technology at BASE Bahay Foundation in the Philippines. And today I want to share with all of you not only what we are doing in our innovation center, but also a project that is really interesting in collaboration with communities and how this technology can help people that is really in need. So before we go into the project itself, I want to talk a little bit about the Innovation Center and why this is important for us and for the Global South. So in 2021, Hilti Foundation and BASE Bahay decide to launch the BASE Innovation Center. This is a research and laboratory that can test structural components and characterize mechanical properties and do other kind of stuff. And this is important because bamboo construction has been used in the global south for thousands of years. I mean, people in the global south have been living in bamboo huts and bamboo houses for thousands of years, but it never was taken as a structural material. The reason is clear. The development of the structural engineering happened in the North Hemisphere, in Europe and the US, and there is no bamboo there. So it was never thinking as a structural material. But in the global south, it is. So now things are changing, and this is a great opportunity to have a laboratory in a place where the bamboo is available and allow us to work in the research. So this is a short tour in the lab. You can see the laboratory. We have a universal testing machine. We can test different properties, different species. We also have another equipments like this reaction frame with a dynamic actuator where we can test full walls, trusses, and connections, and everything that we need. And even a full-scale model house that allow us to teach the carpenters, the contractors, the engineers how to assemble the houses. So this is a typical 30 square meters house, the typical solution we offer in the Philippines for communities. Okay, so having this laboratory allows us to have alliances with different universities. We have 7 local universities, 7 international, plus other organizations. Our partner in Switzerland is ETH. Actually, yesterday we were there presenting some results of our research with them. In the laboratory, we can do material testing, connections, components like walls, and these are just few results. I am not going to stop here to show any data, but we are doing mechanical properties, we are doing connection tests, we are doing walls testing to understand and to get the data that is needed for building codes in the future. You know, one of the challenges, as Pablo was mentioned, is that there is no building codes. So if you are an engineer or an architect and you want to build a bamboo house, let's say in Indonesia, you cannot do it. You cannot get a building permit. And the sad part is the material has been used for hundreds of years, but people cannot access solutions. So we are doing this. In Switzerland, our main partner in research is ETH. So actually, this whole project started as a thesis of a Hilti engineer, Corina Salzer. She was doing her master in ETH. And because the idea to explore housing solutions in the Philippines using bamboo is how this BASE Bahay concept was created. So actually, Corina imagined the entire concept of BASE Bahay, and later on, I joined as a technical support. And then, I mean, 10, 12 years ago, we were like 2 kids running in the Philippines, trying to see how we can do this. But the topic, well, this is some publications we do. The topic I want to show you today is this project. It's a project very interesting. This is the Maranao House, is the Torogan community in the southern part of Philippines. There's a strong community, very well established of indigenous people. There was some political issues with these communities in the past. There are some rebels groups trying to fight for their independence. And in the last 10 years, Philippines started a peace agreement process, and this end in the creation of the Bangsamoro Autonomous Region is still belongs to Philippines, of course, but it's an autonomous region. So now these communities require solutions. They need houses. They are indigenous. They live in the countryside. So as you can see in the top, the vernacular house has some characteristics that are unique of the culture, that takes their cosmology, the life to the way they live, and the solutions they developed in the beginning was more urban, more semi-urban. So you see there is no like any connection between the two solutions. So our design team worked together with the community to understand their needs and their concepts, and we end creating a kind of a fusion solution between our technology and their needs. So this was the result of an set or many meetings we have with the community, understanding what they want and what parts of the houses they could be more flexible to change and with others no. And then we end doing this house. The house that you're looking at the left side was our first model house. It's a two-story house. And later on, we are working on a little bit bigger solution that even adopt more of their traditions and the way they live. So you can see here the model, the first model house is this one. It's a 55 square meters house, two-story. And in this picture, you can see how was the interpretation of the traditions and taken into the house that now we are proposing them. But here there is a lot of challenges. You know, Philippines is a country with 20 typhoons every year. So you need to resist typhoons that are up to 220 kilometers per hour. And this design with all those open overhangs is not actually something that you can do it easily to resist typhoons. So the solution here was to make this core, the central part that you see there in red, is a core made with the CVFT that can resist up to 200 kilometers per hour, and it becomes like the part of the house that they can be saved during a typhoon. However, the eaves can be broken during the typhoon. They can be destroyed. It's like some part that can resist maybe 100, 150 kilometers per hour, but not 250. But the important is to keep the people alive and safe inside this core. If they survive, they can repair later on the house. That was the main concept or the structural concept in this house. Some pictures of the construction process. It was for us also an experience. As you see in the Pablo presentation, our system is a prefabricated panel system, quite semi-modular, easy to assemble, easy to build. You build a house in 3 weeks, it's quite quickly. Here is totally different. We could produce some panels prefabricated. Most of the house is like a big handicraft that you need to do element by element and connection by connection. But this is the kind of projects that these communities like to have because it's the way. Here we sign an agreement. You can see in the picture Pablo and Maricen with all the community of the Bangsamoro Autonomous Region. This is the Walay house. It's a little bit bigger with different spaces when they can have their own traditional activities. This is 75 meters in area, and we are doing the construction right now. It's not yet complete. We expect to have this house finished by February this year. So we will send you the pictures of the final results. And all other projects aside of the construction of houses in the Philippines, we did the first EBB in India with the MO there with Hilti India. We did 2 houses. Trying to transfer the technology to a local partner there. It was a very successful project, and this year we expect to do more houses with them. In the Philippines, we also help other organizations to build orphanage, weaving centers, even office for producers of bamboo, school buildings, and local markets. So it's not only limited to housing, it's also helping the communities to create healthy environments, houses that are resilient, but at the same time more green. And I want to say that the houses that we build are not sustainable. That's not the word that we should use for our houses. Our houses are regenerative. Why? Because we are carbon positive. So when you are carbon positive, you are taking more carbon than the carbon you used to build. And that's the only way we can fix the problem that we are having right now in the planet. We need to do restorative constructions. Sustainable is not anymore enough. So that's the presentation I have for today. Hope you enjoy it. And if you have questions, we are ready to. Thank you very much.
Thanks. First question is here already. I would also like to invite our online participants to send their questions via the chat. Marcin, if it was just in front of you.
Is it? Okay, sorry. Yeah, that's a very good question. Thank you. Yes, it's a big challenge to change regulations. We know that structural engineers are very conservative, so they are not very open to these new technologies and initiatives, and even more if they are from vernacular materials. But the world already have some building codes. So the first one was written in Colombia in 2002 after a strong earthquake that kills like 2,000 people. And a lot of bamboo houses, all bamboo houses in the coffee region survive. So the engineers say, okay, let's research this and then include it in the building code. Later on, Peru, Ecuador adopted as well. And the new time, ISO, for example, has a committee for bamboo standards where a standard, ISO standard for bamboo structural design was published in 2021. And we are trying to convince slowly governments, like we're working with the Philippine government to convince them to introduce bamboo in the building code. It's not easy to convince structural engineers. They are quite stubborn. I'm a structural engineer also, but we need to convince them that do it. But it's one of the main objectives of the BASE Innovation Center and BASE Bahay, together with Hilti Foundation, to start to lobby and convince more countries to adopt, because we know it's a key part of the equation. Without regulation, it's harder to do houses.
I think when you ask for the collaboration with government, the building codes, we still see an openness of the governments to work with us because they're interested in passing on standards and regulations. It's a difficult task, but it's doable in a sense. Where we have more challenges is in inviting government to invest in social housing from bamboo. And that's where the real challenge starts. How do we convince them when they do social housing, if they do at all, why they should use bamboo as a building material, because they have the same perceptions of bamboo as anyone else does. And also, can we help governments to invest in or give incentives for green construction? That's also a big challenge in many countries in which we work. So we work with government on many fronts.
Also, to add on to that, we try to give it a two-way approach. The bottom up, we work with Association of Structural Engineers of the Philippines. We provide them all the design guidelines. We drafted a whole chapter to be added into the building code just to be able to educate all the structural engineers. We tried to lobby with all civil engineering organization. That's bottom up. On the part of Johan, it becomes a top to bottom approach. Lobby the House of the Senate, the House of the Congress, and all the local government units, because we're already building houses. We have already built 1,500 plus units through the local government units because they would approve a building permit. And also the design, the technology, we already have a certification from the Philippine National Housing Authority. So it would be a top to bottom approach and a bottom top approach. So it's a midterm direction, but there's a lot of experience and expertise we have right now in Hilti and Hilti Foundation when it comes to bamboo. We have the leading authority in terms of codes in Latin America, pull it to the Philippines, to Asia, and that would help. We're now working with the national guidelines for this type of material in Nepal and also in the Philippines. I'm sure it would be a long way also even for the US before this gets fully integrated into their codes.
More questions, please. Marison?
Thank you. I have a question. I saw you used wire mesh for the plastering process, and using bamboo, I thought, why not use a bamboo mat rather than the wire mesh, which would make it maybe even more sustainable? And the bamboo mat, I think, physically could be as good as steel. And yeah.
Actually, we have it. We have the two systems. In the beginning, we started with the metal mesh because these bamboo mats or flattened bamboo was not available in the market in the Philippines. So we have to train the producers how to do it. And right now we have both systems, the metal mesh and the bamboo mat with a chicken mesh and the plaster, of course. And definitely the bamboo mat wall is superior in terms of carbon sequestration, thermal insulation, more ductility when you test it in the lab. So it has a lot of advantages, except one, fire rating. So when we test the walls in Indonesia to fire rating with the bamboo mat, we get only 1 hour. And in the Philippines, it required to have 2 hours of resistance without allowing the fire to pass to the next house. So the metal mesh give us the 2 hours rating. And then in most of the projects right now, the firewall between the two houses, we do it with the mesh, but the rest of the walls with the bamboo mat. That's the movement we are having there. Yeah, but what happens is the bamboo has ignition by himself for the heat, and the mesh lose all the qualities wherever, but the fire didn't pass. And that's what the fire rating asks us in the Philippines. So, but we are trying to look in all the possibilities always.
You mentioned that bamboo grows relatively quickly, 3 to 5 years. As timber construction kind of picks up all over the world, do you see the potential for bamboo to be used in other structural timbers like OSB or glulam?
Yeah, absolutely. That's another field of work. Actually, the Chinese are very strong in doing laminated bamboo, engineered bamboo, and they are doing even mass bamboo panels that are very heavy. Actually, the density is 1.1 or something like that. So complicated for construction, actually. But there's a field. The problem when you do mass bamboo is the use of glue compared with mass timber. So in mass timber, you have sections that are 5 centimeters and you glue all of them. In bamboo, your sections are 1 centimeter and you need to glue of them. So the consumption of glue is so high that the carbon emissions also goes up and you lose all the green properties of the bamboo. But the still bamboo is so that good that it balances a little bit. But there is a potential. There's a company actually in the US. It's called Bancor or something like that. They do a kind of cross-laminated timber, but in the core, they put bamboo, and the 2 layers in the exterior are wood. So they are doing a sandwich there that combines bamboo and wood, and they can skip the regulation also because still is a wood panel, but use bamboo, and they take the better properties of the bamboo in the core of the panel. So there's a lot of potential, and the market will continue to develop. In BASE Bahay, what we are looking in BASE is for the low-income families. It's a low-tech technology that is easy to replicate in any country in the global south and any island in the Philippines. But also in the innovation center, we are looking for technologies more complex to develop, also to offer in the market.
So you mentioned that you started with the low-income families, and that's obviously understandable because it's solving the housing issue. Now, when you try to convince the governments to approve it in the code, does it make sense to show off kind of a bit more, let's say, ambitious, structurally ambitious projects of multi-story, etc., because it's a strong structural material could build also bigger things to convince that this is kind of mainstream?
Beautiful, very good question. Because if you focus only on socialized housing, it's a small group and the influence is very limited. And once you talk to the local government units, They would be interested in school buildings. They would be interested in commercial centers. They would be interested in community centers beyond the basic socialized housing you offer for low-income families. And we recognize that. And that is also one way to open up the advocacy to different hierarchy in the market. So now we started looking in school buildings. In the Philippines, there is a separate funding for socialized housing. There is a separate funding for education. There is a separate funding for women empowerment, and all of this funding can be accessed and can be used, can be tapped using different kind of structures. So also, if we would like to open up the market and make bamboo a material for the mainstream, so we should be able to demonstrate the capacity of bamboo as a construction material, not only for this sector, but goes all the way up. And we recognize that, and that is a good strategy to open up the market.
I think what's important to understand is how we transition with the BASE Bahay Foundation in how we work. When you look at the early years of the BASE Bahay Foundation, it would have been us who built the houses, but also who work on the entire supply chain to harvest the bamboo, to treat the bamboo, and then to execute on the houses. And especially in the early 3 or 4 years, it would have been Hilti Foundation to invest in the construction of homes. Today, we take a completely different approach. We try to enable a market that delivers on bamboo construction. And this is really across all levels of construction, be it special structures like schools or community centers, be it social housing, but also we are happy to cater to needs of low middle income families, of housing developers, or even high-end construction like resorts or similar. But we are convinced that enabling the market will always benefit low-income families in the end, because bamboo is an ideal material for low-cost housing. And in the Philippines especially, and also in Nepal, we continue to focus our efforts on making the market work for low-income families. Sorry, there was another question.
Maybe it's more for Luis. I'm interested in the proportion of how much cement, bamboo, and steel you use for the affordable housing, which is a bit different than the other one with the core. Yeah, and also the price per square meters.
The proportion of steel and cement and concrete compared with a concrete house, we use only around 15% of the concrete that a concrete house uses. 15, only 15. So that's why when we do the life cycle analysis, our houses are so good compared with the concrete houses. So yeah, including the foundation. Actually, the foundations are smaller because they are twice lighter. So it's quite small, and everything is small in terms of concrete, and then the reduction is very high. So comparing carbon emissions only, life cycle assessment, the house is 70% lower compared with a concrete house, with the advantage that also has carbon storage in the bamboos. So that's very good. And regarding the price, right now, the square meter in Philippines and Swiss francs, it's around 5,000 US dollars at 30 square meters house. That compares with the conventional construction in the Philippines is around 30% lower. So the houses, it varies depending on the island and the region. Logistically talking, Philippines is a complex country because it's an archipelago, but we are in the range, and most of the times lower than conventional construction.
Sorry, can I? Hi, my name is Marisa Halandone. I'm also with BASE. In terms of cost, these are cost comparisons in the Philippines, but of course, and these are for the social housing. Earlier, there was a question on how we can promote bamboo in other applications, and definitely all these applications will depend on the per square meter cost. But right now, in the social housing or the affordable housing segment, we are at about the 30% cost reduction.
And on top of that, aside from, because you're working on affordable housing, so cost must be, and so the passive design, the construction method, all should fit together so to achieve that reduction in cost On top of that, you know, for a 30 square meter building, you have a carbon avoidance of about 10,000, 74 reduction in about 9,000 tons of CO2 per unit, because the structure is lighter, the structure is lighter, and then the use of the material. Compared to the carbon avoidance is always compared to a concrete hollow block structure that you regularly use for this type of construction.
I think there was another question with Olga.
Thank you very much for amazing presentation and very engaging materials. You really had a lot of our attention, and it was really fun and interesting. My question would be then straightforward. When do you think we can expect something like this appear on the Hilti campus, so in Liechtenstein or in Switzerland?
I'll pass on to our engineers in a second, but from my view, the biggest problem has been we haven't tested resistance to snow. We've checked a couple of times if we can build a bamboo house here on campus. So maybe you want to comment, Luis.
I am ready. Let's do it. The only way to know if it will be resistant to snow is by doing so. We can do a full-scale test with the snow here. I mean, that will be a great project. One of the challenges is to get the bamboo. Of course, there is no bamboo of that size in Switzerland, so we need to look. But the good news is that there is new plantations happening in Southern Europe, in Italy and Portugal and Spain. So they are now establishing plantations with bamboos that are structurally sound. So maybe in 1 or 2 years they will be ready, and then the possibility will rely in Hilti Foundation.
Question to Lena. Any questions from online? No. Good. Then I think we have time for 1 or 2 more questions, please.
Thank you very much. As you've been talking about the different stakeholders in this field, I was wondering, and you've talked about all the specifiers, the engineers, the authorities, regulators, whatnot, construction companies, obviously. How about the acceptance of the end users? Was there any hesitance regarding that type construction or the houses built of them?
Okay, then I start. The answer is yes, there has been a lot of resistance. And it's mostly because those families who've built with bamboo over decades and centuries, the very low income families, they are the ones who have seen their house collapse in the first storm because it's been executed very badly. Bamboo is also known as the poor man's timber. And there are very few examples of strong bamboo structures that actually withstand wind or rain or typhoons. And that causes the bad reputation for bamboo. And also, these families see how mid-income families build, and mid-income families build with cement, and that's aspirational for them. So changing these mindsets is one of our most important and biggest challenges, actually. And we haven't really found the one thing that turns around perceptions. We do believe that the building codes are an important element of it because it really helps making bamboo more mainstream and more standard. But obviously, it's also about building examples where people can see bamboo as an aspirational and strong building material. That's what we start to do with our school buildings, for example. But it will definitely help when we see more resorts using bamboo, even though it's not our first and priority target group as a foundation. It will help improve the perception of bamboo as a building material.
So you mentioned that bamboo housing is not sustainable but regenerative in terms of CO2 offsetting. I mean, Hilti also has a program for that, and we invest also, I think, quite some money in it. Wouldn't that be a market to address?
It's a very complicated topic. For a carbon credit for a house, let's say for a house, first you need to have a methodology accepted by either Vera or Gold Standard and right now there's no such methodology for this type of material and this type of structure. There are methodologies for bamboo plantations. Let's say for every hectare of plantation you build on bamboo, you can get about 10,000 CO2, equivalent CO2 per hectare. And that is verified, and there is a methodology that credits that amount of CO2. That's for the plantation. Now on the product side, for the house, so we can only quantify right now the total carbon avoidance or the total carbon sink. But we can do that by research, and we're doing that through ETH Zurich. And that's why we can say 74% of the carbon emission has been reduced in comparison with your conventional construction. And that is research-based. But the methodology accepted by Vera or VCS or Gold Standard, there's no such. And we are still on that process of looking for that right methodology. Would you like to add?
Thanks, PJ. Yes, so it would be very interesting and very intriguing to find a way to sell carbon credits and reinvest the revenues into our houses. We continue to work on research and to drive such methodologies, but we believe it's a minimum of 5-year journey, if not more, to really make it work. One last question, or otherwise, let me check online. No. I suggest there's lunch at the end of the room, and I'm sure colleagues will stay around if you want to ask more questions in a personal conversation. We're happy to be available. Thanks so much for joining us, and thanks for